Okay, let's start and let's talk about the exist function. So we can use exist means the situation just English, right? So you say the situation exists or not. And we can also similarly, we can say where, right? So we have where clause and we can say not exists. And then we have the condition here. And so let's do a quick in-class exercise here. Let me give you 3 minutes on this one. So working on this query by yourself, and you know the schema is this one, right? Also, the slides, previous page of slides also have the schema. Okay, so working on this. Okay, all right, so let's see how to do this. What we need to do here is we follow the same logic, right? We want to output the employee table for qualified employee. And I just want to see if this one has dependent or not. And I want to see have no dependent, like this is not qualified and this one has no dependent qualified, things like that. So very similar, but now you don't have to use exist. You can use not exist here, then you'll solve the problem. So this is a good way to practice the nested query, right? So let's see, the from part is from employee table. And we see E dot first name and E dot last name. Okay, and the where part is set not like this, right? And then we'll see what are the situation here. And what we need to do is I want to select from the dependent table. And this is actually coming from the dependent table. It's D here. And then we'll see, I need to make sure this is dependent related to employee. So I say E dot SSN equal to this dependent ESSN. And this is the only condition. And I want to see if it's empty or not. So I can select all the attributes. So I do star here and I end with semicolon. And remember that for any query, even create table statement, you have to use this to indicate, tell the query processor, I'm done with this whole query. So that's what we have. Yeah, that's it for the exist. Okay, so this one, the set already finished. And let's talk about renaming of attributes. We can see, we know we can use as here, and that's the front part. And we also talk about we can use as in the select when we talk about arithmetic calculations. This is the case, even you don't have any calculations, you can use as, simply as means give another name. So in this case, remember this is the case to have supervisor related information. So this part should be, wait, so how, I'm not able to modify. Okay, so if I don't select the pen, actually, this one should be there. Okay, I'll just try the super assistant on. Okay, all right. So this part should be there. Okay, so no space. Okay, so we have employee's name here, and this is a supervisor name. So they are just two new column names. So to make the result looks better, you sometimes when you have this kind of case, you want to explicitly tell what a column means what, right? So this column means supervisor name. Okay. All right, and then let's see join tables. This is something we did before. So we want to get the research department, right? So research department employee, this particular one, the black color one, this is when we did one single block. We did a nested query also, right? So another way to do the same query is using this one. That is, we explicitly using join here. So you see, instead of say employee comma department, we can say employee join another table here. And then we specify the condition on. So this one, when we have students like computer science student, we train student with relational algebra, right? So easily, you know, I have one table join another table, and that's the condition here. And basically, they are translated into R join S, right, on the condition C here. Okay, so remember, SQL is a declarative. So we can have people, for example, from business school, they learn SQL, but they don't know anything about query processing. They know nothing about relational algebra. So they may not understand the join means what. So this way, be able to just simply they tell the query processor, I need two tables. And rather than know there's something called a join operation, but for us, you can use this also. So they are both legal syntax in SQL. Which one you want to use is more personal preference. Some of the system has some restriction on using join. So this is more like a traditional way, everywhere separate, accepted. And some of them have certain restriction on join. However, MySQL actually pretty much prefer using join instead of using that. And so when you working on 134 class, either way is okay, they will accept it. Yeah, depends on, you know, your habit to working on the queries. Okay, so next topic I want to cover is, hold on. Okay, the next one I want to cover is the inner and outer query. So what is the inner query? Inner query basically is the, I'm sorry, inner join, outer join. I was thinking about something. Okay, so inner join and outer join. What is inner join? This is the same as join operation we just covered here. Okay, so the reason we put it in there because I want to, you know, compare with outer here. It is a default type of join in the join table. And when you say join here, it is default inner join. So in other words, instead of say join, you can do inner join. So put this one in or put this one in, give me the same result. It just default this one can be cannot, you don't have to show inner, it will give you the inner anyway. So we know that we already know what we define in relational algebra, what is the join operation. So the result only show when we have the matching method condition, right? Okay, so that's basically what we have. And also, if you use this way to answer, it is also inner join by default. So if you want to use inner join, you can use this, you can write down this. You also can just, instead of join, you can write inner join. But there's another thing possibly useful, that is using outer join. And when we have a tuple not exactly match, but we want to make a part of the join table to show up no matter what, that's the time to use outer join. So for outer join, we have left outer join, we have right outer join. They are just purely by position. So we have R, right? And if we say R left outer join S, R is on left side, S is on right side. So this is a purely on position. So if this R left join S, every tuple in the left table, that's R, must appear in the result. And when we have join, remember we have the condition that they are not matched and they don't have the matching one. If that's the case, we just padded the null value for that attributes on the right table. And the right outer join just flip the whole concept. Everything in the right table must appear. And if there's no matching, then we're going to pad with the null value also on the left side. And usually the left outer join is more popular. It's just more like a human's tendency to make something on the left, all show up, and the other side, we are okay to pad them with the null value here. And once I show you an example, you will see the difference. Okay, so let's first go back to review the inner query first. So this is just, so for example, put inner, that's fine, same thing, right? So this is a join, you also can use the comma, remember? Okay, so when we do this, we actually take department table and employee table, only we have this condition match. So it's like this case, right? So in this one, the manager assistant and assistant match. So this is the manager for administration department. That's why you have this result. And this is the research department manager. And we can have many other employees, they are not a manager. In this case, their assistant, this condition is not matched, right? So that's why we don't see it in the output. This is consistent with everything we learn for the join operation so far. Okay. So the new one today is the outer join one, right? So let's first see, okay, and you see the result. We're going to go back to this. Let's see, when do we use outer join? What kind of case like people use this? Okay, so still about employee and the department they manage, right? So in this case, if employee manage a department like administration department manager, when we have that, then we want to see administration as department name. If an employee do not manage one, okay, so we'll have some employee, they are not managers, and so they do not manage one, we can indicate with no value. That's the case, basically told me all the employee I want to see. If they happen to manage something, I want to see. If not, then give me a position holder here. So that's the case. If we see the result, we pretty much looking for a result like this. So I need all the employee name here. Okay, so the first one, Lisa, is the manager of administration. So that's why I see the matching, right? I see the condition here. And then I be able to put this in, and that's actually the same thing as this one. Okay, and then we move on to the next one. This one does not manage anything. So no department, this is not a department manager. So we need to put no value here. So as a result, we're going to continue, right? So we will see, we have a couple of them just because they are not a manager. And this is the manager, this is the manager, and this is the manager. They are the manager here, right? So now you see the difference between outer and the inner join. And let's go back to see the query here. So we can see we do select and from, and now the position matter. So we want to see all employee name. And if you put the employee on the left, you want to use left outer join here because this is on the left side. And when you do left outer join and department means this is on the right side. And if we compare, you see the left one and this is the right one. Okay, and then we'll say something join something on, and that's the condition. So this is the case when we have this match. So we have this condition true, and this is condition false. We don't have any join set. We don't have this one satisfy this join condition, so we put this in. So that's for the left outer join. If we use right outer join, it just flip the whole thing, that's all. Yeah, but you need to make sure satisfies query that actually the query need everything about employee, right? Okay, so when we have inner query, you do have more than one way to answer this. But for outer query, you just say left or right, depends on what is the logic there. Okay, so that's for this one. And now let's move on to something really powerful, and that's called the aggregation function. So we know when we run SQL query, not only we want to get the raw data coming from the database, but also we prefer to do certain calculation. And of course, one way you can do is you get the result out. Say I want to see which is the maximum salary. Then I can get all the salary, and from the salary, I'll just check which is the highest one. And it's not that convenient because in many cases you want to run a query, get everything. So that's why we have those aggregation functions. So they are embedded function in the SQL vendors product. You can use them directly. And later in the 174 class, you will learn how to build a customized functions. So you can write your own functions. So the function I introduced here, they are just standardized function provided by SQL because they are frequently used. Like for example, max, min, average, sum, they are pretty, straightforward to know the meaning, right? And I will do the count later in the next slides. So let's see how to do the max salary. Let me start with the simple one. So if I do select from employee here, and if I do select a salary, what I can get is salary, and then I have the salary information here, right? And the aggregation function is applied on top of it. So if you have trouble understanding aggregation function, you can think about this way. First of all, we can have a query without that. Then once we apply aggregation function, say max, then it's the same as go through the salary. And I found out, for example, this is 200K, and that's the highest one. Then my result will be, okay, so this is the result without a max, right? So just this part is this. And now let me have max here. Then what this query can produce, let me use a different color. So this particular query will produce things like that. So I'm going to get only one column. And a lot of cases when we're using aggregation function, we want to use the S keyword to say max salary, for example. So okay, so we see max salary here. So I have only one column. And this one column, right, I also only have one value, for example, 200K here. So that's what happened for aggregation function. Okay, so for your own function, so this is a standardized, the aggregation function is standardized in SQL standard. So most vendor, they provided this, and you can use this directly. In 174 class, you will learn, not this one, the one higher than this, you will learn how to create your own functions. Then you can use your function in a query. Not this class though. Okay. And so we'll have this result here. So you see the aggregation result, like this one, it actually gives you only one thing, right? So one row, one column, one number here. And you will see we actually were going to utilize this feature very soon. So that's what happened for aggregation function. We can also specify more than one. So we can see max, min, and average salary. So in this case, we will have, so for this particular query, let me change to another color. So in this particular query, I'm going to have 3 columns, right? 1, 2, 3 columns. And I have 3 columns, right? And I have only 1 row, 1 tuple here. And that's whatever the max, min, and the average salary correspondingly. So regarding the name here, so if we don't rename this like as keyword, if we don't do that, then it's up to the DBMS system. Some of them, they just put this whole thing as the name here. And some of them, they just make this whole thing empty. So whenever you have aggregation function, if you want to see a nice output, you probably want to use the as here to rename like what I did here. So you'll be able to see what the column name as the way you name it. Okay, some of the SQL implementations of some Windows product may not allow more than one function in the select. Okay, so this is actually once we learn aggregation function, a lot of things like the one we learned in the previous lecture, we learned the things like all, remember, in the sum, and they can be rewritten as using aggregation functions. And most people feel this is actually easier compared to others to use. And they are also very helpful when we use that in a nesting query, right? So subquery can do certain things, and you can do the comparison between the outer query result like in the where clause. Very, very convenient. Before we do that, let's do a simple one here. So let's do a simple, let's do a quick in-class exercise to see if you understand how to do the aggregation function or not. And remember, the whole thing we learn is if you don't know how to use, simply do without the aggregation function, then you apply that on top of it. So means whatever we learned before still applicable when you use them. It just the last step you put the salary like max min on top of the attributes. That's all. So let's do a quick in-class exercise. 3 minutes. Okay, so let's take a look about how to do this. So we do a select from where. And this is again the employee for research department. So remember we have a couple ways to do this. And what we can do is DNO equal to the number and the name. Go to research, right? And the select part. So if we just do the salary, then we get to the salary. But this one asks you max. So I get a max and the next one is average. All right. Okay, so that's for this aggregation function. So if we move on to the count, this one handles things a little bit different. So we say select a count from employee. This one will count how many rows. The number of rows here is not actual values, right? So like we do the max, we need to see the value of each salary to know the maximum salary, but this is what we only care about how many rows. So that's why in many cases, when you do count, we see the star because the column name actually doesn't matter. I want to see just how many rows. So let's see this one. Again, when you do any aggregation function, if you have trouble understanding it, just do without an aggregation function. So in this way, when we do select star from employee, we have, say, all the employees here. Then when we have a count on top of it, so we count this one, we are going to say 1, 2, 3, 4, 4 employee. As a result, my result has one column, that's which I will count, and one row, right? And this is a 4 here. So that's something unique for aggregation function. And you only have like one value in this case because only one column, right? So that's something different. You just count the rows and to get this. Okay, so when we do the count, when we select distinct salary or salary, you're going to have different result. So it all depends on how the query get asked in order to know which is the correct answer. So when we see count the salary, that's basically we count every single salary there, but this is distinct, only distinct salary will be there. So each of them, this one give you a number, this one give you a number also. Let's see this aggregation function. This is the one to use the count here. So that's actually very similar to what we just did, right? So let me write this down. Okay, and we want to see if we do a star, that means everything satisfied the condition. And since I want to know how many, I just do this. Okay. Okay, so that's just some simple aggregation functions. And now let's do a more complicated one. This aggregation function allow us to make tables comparison. We did like exist, not exist, right? Now we can do even more. We don't have to be restricted by empty or not. We can count how many. So in this case, I want to get the name of employee who have 2 or more dependents. So if we think about this way, I need the employee. So employee in the outer query, for example. And for each employee, I want to see, so this one has, say, 3 dependents. I want to count how many, so 2 or more. So this one has 3, then this one should be in the output. And this one, for example, only 1 dependent, then not. And this one has, say, 5, then yes, right? So we can do the same way. The outer query, query the employee table, and inner query, query the dependent table, and to count how many. So let's work on this. And we actually utilize the feature of aggregation functions only have 1 row. And I'm going to show you in a second. So in the outer query, we're going to utilize the employee table. Okay, and then we're going to take the employee's last name, the employee's first name. Okay, and then the where part, okay, we don't need to put exists, not exists, because in this case, we are going to compare something is 2 or more or not, right? Okay, and what we need to do here is I can write a query, and this query, let me just, without comparison, just count how many dependents. How about that? So this is dependent, I want to count them. And so how to do this? I'm going to write a query to do a count. So this is one coming from dependent table. Okay, and then I need to make sure this dependent is the actual dependent of the employee. So I'm going to do e.ssn equal to dependent.essn, right? So this is the way to make inner and outer query related. And I'm going to do a star. That basically means all the dependent. And then I want to count, right? I need to know how many. So I'm going to do a count here. So this way I'll be able to say, oh, this one give me 3. However, in this whole query, remember we talked about what it looks like here, right? So eventually give me, we'll do a count, it give you a number here. And this is still, whenever you run any SQL query, it's a table structure. However, because aggregation function has a specific feature that is 1 row, 1 column, and in other words, it gives you 1 number here. Like in this case, just 1 number. So this one also give you, for each of this, right, for this particular one, with this matching, I'd be able to get a number like number 3 here. So that's a 1 number. So in this case, SQL, this particular syntax on this part, instead of treating this whole thing as a table, it treated this one to produce a result. This is a table, taking the result from the table. So like this case is 3, right? So it's a number here. And just because it's always give you 1 row, 1 column, give you 1 number. So taking the number inside this table, so that will be the result here. And I want to compare this table's result number with another number. So has a 2 or more. So this should be greater than 1, right? Okay. So let's see, we use a couple things like the inner outer, just like what we did before. We can use, inner can use outer queries, variables, everything, right? Also, you know, this is the one you want to know. Sometimes when people using nested query like this, just people put whatever they want, but you remember you have to follow the grammar. Otherwise, query processor will confuse, don't know how to do, right? So, so in order to handle this, just treat this whole thing as a number. So a number can compare with another number, and it will satisfy the condition here. Okay. And not only we can do this, but also this where part. Remember this whole thing, where clause is a true or false, eventually return. So we can think about, and maybe using another color, maybe this one. This whole thing is one condition. You can have another condition, so you shouldn't have this. So you can have this condition, and you can have another condition, right? And you can have another condition. So we can have many conditions, and the people, it's all like the habit, right? Some people write the condition ahead of time, then you use this, the subquery as the last condition, but doesn't matter because remember condition C1 and C2, right? It doesn't matter C2 and the C1 give you the same result. So you don't have to put in the front, you can just put this way. So that's one condition and a condition. In this particular example, we don't have another condition here. Okay. So another common problem is people try to use when they, when you answer aggregation functions, they try to use a count in the where, and you cannot use directly. It's actually no matter count or max or something, they need to be in the select clause. And you may ask, you did this in where, right? But I actually, the reason I put this in where is because this whole thing is a nested query. So this part is a query, and the count is in the select part. It just the query result give you a number. That's why you can do comparison in the where. So make sure you understand the logic here, just beyond the question itself. Yeah. Okay, so we're going to do in-class exercise. You are probably not going to finish it by the end of this class, but I'm going to cover that in the the answer in the next class. And you can try to see if you understand how to use the subqueries to handle aggregation functions, to handle more complicated problem. So I just feel like using aggregation function in the subquery open a door to solve the type of question that you can compare the numbers. Okay, so this query asks you to choose each employee. Okay, so when I say each employee, it's the same as all employees, okay? Okay, so the daughters is in the relationship of the dependent table. Okay. So we'll do this as an in-class exercise, and I'm going to cover the answer for this in the next class.